So now, after deriving the trigonometric ratios for 45 degrees, now let us focus on the values of trigonometric ratios for 30 degrees and 60 degrees. Let us see what the values are and how to derive them. So basically, you know that the trigonometric ratios for any specific angles remains constant throughout whatever the triangle is. So taking advantage of this thing, consider a equilateral triangle. Let us consider an equilateral triangle of side of unit length. Say this is 1 unit, this is 1 unit, and this is 1 unit. Let us name the triangle ABC. Now you know that in an equilateral triangle, the height acts as the median as well as the altitude. So let us draw the height of this triangle. So this will be the altitude, and you know that this altitude will divide the base into two equal parts. So I'll say this point is D, so this will become half and this will become half. Now if I'll apply Pythagoras theorem, to triangle ABC, then I can find the length of the height of the triangle. That is, I can find out what is the length of AD. So I can write 1 square is equal to 1 by 2 whole square plus of AD square. From here I can get AD square is nothing but equal to 3 by 4, which implies AD is equal to root 3 by 2. So now I have this AD as nothing but equal to root 3 by 2. So now I have all the dimensions of this triangle. I know the length of AB, I know the length of BD, I know the length of AD. Now it is very well known that in an equilateral triangle, each of the angles measure 60 degrees, right? So this angle is 60 degrees. This is also 60. This complete angle will also be 60 degrees. But if I'll ask you, what is the value of angle BAD? That is this angle, can you tell me? Yeah, you're correct. Obviously, this will be 30 degrees. Why this will be 30 degrees? Because the triangle ABD and triangle ACD are congruent to each other. This side is equal to this side is equal to this side, and this side is also equal to this side. So by SSS congruency, both are congruent. Now since they are congruent, so this angle is equal to this angle, right? So this complete angle was 60 degrees. When divided by 2, this will be 30 degrees and this will be 30 degrees. So now all the things for this triangle are known. So now let us come to finding the trigonometric ratios for this triangle. Let us start with 60 degrees. That is, I am considering angle B because I know that the measure of angle B is 60 degrees. Sine 60, you know sine is the ratio of perpendicular by hypotenuse. The length of perpendicular AD divided by AB. Now AD is nothing but equal to root 3 by 2. So sine 60 is nothing but root 3 by 2 divided by 1, which gave me root 3 by 2. So sine 60 is root 3 by 2. Similarly, if I'll ask you cos 60, cos 60 is the ratio of base BD by hypotenuse AB. Now BD is half and AB is again 1. So this gave me cos 60 as half. Then I have tan 60. Tan 60 is perpendicular by base, that is AD by BD. Our AD is root 3 by 2 and divided by BD is 1 by 2. So this ratio gave me root 3. So tan 60 is nothing but equal to root 3. So now I have sine 60 as root 3 by 2, cos 60 as 1 by 2 and tan 60 as root 3. Now you know that cosec 60 is nothing but 1 by sine 60. So cosec 60 is inverse of sine 60. So this became 2 by root 3. Sec 60 inverse of cos 60. So this became 2. And finally cot 60 is inverse of tan 60. So it became 1 by root 3. So now I have all my 6 trigonometric ratios for 60 degrees. Now let us come to 30 degrees. I guess now that if you are okay with understanding how we found the values of 60 degrees, now you can easily find the trigonometric ratios for 30 degrees. This is simple. Now, when I'm talking about 30 degrees, basically I am concentrating on this angle because I know that measure of this angle is 30 degrees. So, sine 30. Now, with respect to this angle, BD is my perpendicular and AD is my base. So, sine 30 will become BD by AB. This perpendicular divided by hypotenuse AB, which gave me 1 by 2. Similarly, cos 30, base by hypotenuse, base is AD, so AD by AB. Now AD is root 3 by 2, so cos 30 became root 3 by 2. Tan 30, perpendicular by base, that is BD by AD, which gave me 1 by root 3. Now since I have all these three ratios, remaining three, finding them is really easy. Cosec 30 is 2, inverse of sine 30. Similarly, cot 30 is inverse of tan 30, that is root 3. And finally, sec 30, that is the inverse of cos 30, 2 by root 3. So this is how we derive the value of 30 degrees and 60 degrees trigonometric ratios. And I hope you are able to understand this. And please try to remember these values because these values are the important ones and very important for standard angles.